Chapter 4, Chemical Reactions. This chapter would be all about reactions. Starting with reactions, let's first discuss the differences between chemical and physical changes. Though we have discussed this back in chapter 2, लेकिन एक छोटी सी quick revision. Physical changes are changes जिसमें substances chemically same रखते हैं. The identities don't change. कोई नए substances नहीं बनते, simple mixings होती हैं. Mixings को easy होता है reverse करना. Mixtures easily separate भी किए जा सकते हैं. We have had discussed many techniques back in chapter 2 जिसमें हमने उन्हें separate किया हो. Filtration, crystallization, decanting, distillation. There are many techniques by which we can separate the mixed substances. Chemical changes are different. Chemical changes have some specific features. सबसे बड़ा तो ये नई identity, नए substances बन जाते हैं. ठीक है, पुराने substances से उनकी properties different हो जाती हैं. बहुत सारे reactions, but not all of them are difficult to reverse. आपको energy का expense हर सूरत करना पड़ेगा उन्हें reverse करने के लिए. One of the most important properties of chemical reactions. Chemical reactions energy change भी नहीं करते हैं. Energy give out हो हम उन्हें exothermic reactions करते हैं. अगर energy taken in हो या absorbed हो हम उन्हें endothermic reactions कहते हैं. हमारे पास exothermic reactions की examples endothermic reactions से बहुत ज़्यादा exist करती हैं naturally. ठीक है. So this is a quick review of chemicals and physical changes. अगर change हो तो हम उसे हमेशा equation में या reaction के form में लिखते हैं. उसके लिए आसान तरीन तरीका word equation है. Word equation depend करती है reactants पे और products पे. Reactants usually left पे लिखे जाते हैं equation के और products right पे. Center में एक arrow लिखा जाता है. Arrow English में pronounce करते वक्त हम gives कहते हैं. For example, if you want to say this reaction out loud, it would be magnesium plus oxygen gives us magnesium oxide. Magnesium और oxygen reactants हैं और magnesium oxide product है. Word equations बहुत simple, straightforward और easy होती हैं. Plus signs, arrow signs काफी होते हैं. इसके अलावा word equations में हम कुछ add नहीं करते. For example, hydrogen plus water gives hydrogen plus oxygen gives us water. However, simple equations हमें एक खास method से लिखनी पड़ती हैं. Before we move on with simple equations, आपको एक दो चीजें पता होना जरूरी है. First, law of conservation of mass. Remember, किसी भी chemical equation में वो word form में हो या simple form में हो, एक बात ध्यान में रखनी होती है कि total mass products का chemical reaction में total mass of reactants के equal होता है. Which means that is simple and easy to say. Mass will neither be created nor destroyed in a chemical reaction. We can simply change the states of substances from one state to another state. हम solid को liquid, liquid को gases में convert कर सकते हैं from reactant to product. हम किसी भी तरह की ऐसी physical state change, base changes कर सकते हैं, appearance based changes कर सकते हैं, लेकिन masses total for reactants और for products हमेशा equal रहेंगे. Which brings us to balanced equations. हम जब भी इन equations को लिखेंगे, हम इन्हें इस तरह से balance किया करेंगे कि number of atoms दोनों sides पर बराबर है. उसके लिए हमारे पास कुछ certain set of rules हैं जिन्हें हम follow करते हैं. Let's talk about a few rules by taking the help of a whiteboard screen. First, let's say hydrogen plus oxygen gives us water. Notice you have two atoms of hydrogen here and you have two atoms of oxygen here and you have two atoms of hydrogen plus you have one atom of oxygen there, which does not balance from reactant to product side because high number of hydrogen atoms are same on both sides, but oxygen is not same. First rules first, you cannot change the subscript whatsoever. Second rule, you cannot write anything in between the formulae. You can only write left to it. So what we can do is that we can multiply these oxygen atoms by 2 over here, but in that case, we'll have to multiply the entire thing. So writing 2 over here actually multiplies it by entire thing, which makes us 4 atoms of hydrogen, which means 2 into 2 is 4. So this subscript and this number written on left has to be multiplied And this 2 into 1, this is 1 which is not written over here, but we understood it that is 1, plus we have 2 atoms of oxygen. As soon as you make a change over here, you need to make an equivalent change over here to get the equation balance, and that's what it's all about. So I'm going to erase that one, and I'm getting back to it. So we have 2 atoms of oxygen over here, 2 over here, 4 atoms of hydrogen over here, but we still have 2 atoms of hydrogen. So let's multiply this entire thing by 2, and we get 4 atoms of hydrogen. This explanation written below are just baby steps. What you can simply do is that keep writing numbers over here and do all the mathematics in your imagination, in your mind, and you will be good to go. For example, let's take another equation. Like this. Now we have 1 empty over here, 1 empty over here, 2 oxygen over here, but unfortunately 1 over here. Let's multiply the entire thing by 2. The oxygen is now balanced, but unfortunately we have 2 magnesium over here, but only 1 over here. Right? 2 over here, you're good to go. So it's as simple and straightforward as that. You can keep doing, adding, changing numbers over here, but never to subscript or superscript, never in the center of the formula, always to the left of it. So the whole thing is multiplied. There are a couple of things that you need to keep in mind. When it comes to balancing of equation, it comes with practice, but there are a very small set of rules that we need to go with. Try balancing all other elements first, keeping oxygen and hydrogen for the very end, if they're present as a part of the equation, of course. So you may balance oxygen second last, or hydrogen in the last, or oxygen in the last, or hydrogen in second last numbers if you want to, but balance everything first. For example, if there's magnesium, sodium, or calcium, or chlorine in the equation, try balancing those first before you start off with oxygen and hydrogen. But if you have to, you can get on with oxygen and hydrogen. 1, 2. Secondly, if there is an equation in which a species on left is distributed in many examples on species on right, you need to balance those species at the end. Now let's not go with this equation. This might not be as easy as we consider it to be. Let's just take one species at a time. Okay. In this case, you will find out that oxygen is a part of a single species on the left, but oxygen is a part of every single species on the right, and there are 3 of those. So when you are about to balance this equation, try going with Pb or lead first, nitrogen after, or nitrogen first, lead after, but keep oxygen for the end. The species that has been distributed into multiple compounds are either right-hand side or product side of the equation, or left-hand side or reactant side of the equation. Try keeping that specific element or species for the end, because that's the most difficult to balance. If you balance all the others first and you keep that one for the end, you would be able to balance the equation successfully, most efficiently, and managing time in a very good way. You can also keep writing numbers and cutting them with simple line, single line cuts, and coming up with bigger numbers, so on and so forth. Like for this specific equation, I'm a little unsure whether it was PB or a PbO2. Well, let's try balancing this first. So we have 1 lead and 1 lead. We have 2 nitrogen, but unfortunately 1 over here, so we can write 2 over here. So if we write 2, so that's 2, and that's 4. And now for balancing oxygen, 3 2s are 6, and 6 2s are 12. So that's 2 plus 8, 10, and plus 2, 12. So I think the whole thing is balanced. There are 2 lead atoms, 2 lead atoms. There are 2 into 2, 4 nitrogen atoms, so 4 nitrogen atoms. Because of this 4, I have cut this 2, so please don't consider it. And then there are 3 into 2, 6, 6 into 2, 12 oxygen atoms over here. So we have 2 oxygen atoms, we have 8 oxygen atoms, and then we have 2 more, which makes a total of 12. So that's why I was saying, as oxygen is distributed in between different species on the right-hand side or the product side, so that's why if you keep it for the end, you would be able to balance it easily. If you try balancing it in the start, you would keep ending up with unbalancing other factors first, which can become a headache later. So that's the set of rules that I usually come up with for my students to balance equations. When it comes to balancing up equations, I usually ask my students to balance a few set of equations, like you can try balancing these equations for practice. So I'm going to write a few equations that you can try balancing. Well, these are the easier ones that you can try first. They use smaller numbers and they're somewhat easier to balance. Well, let's write a difficult one too. Try this one, because this one is going to be a little bit difficult. Let's write another one that's going to take a little bit of time. You might find these two equations very similar to one another, except the difference of this one product, but they are going to take different numbers to get balanced, at least a couple of them. Okay. Then in the end, for a very big equation to balance, try balancing this one. And the set of rules I have described for you will help you along the way. So there you go. Try balancing these equations and you can get a very good hand at balancing equations. So a few things are written over here for your added practice. Well, after balancing equations, we'll discuss the type of reactions.